Thank you, Mr. for giving us a brief. On behalf of SEPA, I would like to invite Mr. Dilip by Clean Energy. I hand over the session to Mr. Dilip Kumar on the topic of managing solar PV aspects.
Good afternoon, everyone.
Good afternoon. Yeah, good. How many of you are into installation of solar plants or providing products to solar plants, like modules, inverters? How many of one? Very good. So I think we have equal distribution, and I have people also from the college, and thanks for it. Raghu, special thanks to you for inviting us for this session. So what I'm going to talk about is everybody here since morning or even in the event floor is talking about how to put solar plant, right? And if you see all the targets provided by the government is about let's achieve this much gigawatt, okay? But that is not going to help us until all those gigawatts starts working and generating power. So we should move away from gigawatt installation targets into billions of units or GE generations that we have to generate from the plant. Otherwise, what will happen? You will put gigawatts of plant and they won't work, and your country will become a dump yard for all those cheap products. So our focus is to put plants which will work for the 20-25 years that they are designed for or they are stated for. That should be our goal. And we have industry colleagues who are working on delivering such quality products. And we are here to make sure that the design that they put, the products that they give really works for that 10, 15, 20, 25 years time. So that is what we focus on. And we call that as an ICE way of doing solar PV asset management. So when we say O&M, what happens is people start looking at us very funnily. You have to clean the modules. What is so great in it? So when we go and talk seriously about solar, this is how we look like. Most of them look at us very funnily, like, what are you going to do? It's just cleaning panels, just to look at inverters. They don't understand the seriousness behind managing solar PV plants. So if you look at this, this is another data provided by Kilowatt Analytics. Kilowatt Analytics is a research firm which provides data-related research. They also provide softwares for analyzing data. So this is on a larger portfolio. Between 2011 to 2020, P50 estimates are not being met in US by about 11%. Around 50% probability would have meet 11% of the assets are there. I'm talking about gigawatt capacities of plant, okay, where data is openly shared. Here, even a homeowner solar plant data share, but there they share all data so that they can make better use of the data. And this happens because this is the major challenge. India has the lowest O&M cost, and whatever is not there in other part of the world, we cover it. Let's say this is excluded in Australia, but India, sir, same price I will do it, sir. That is excluded in UK, no problem, sir, I'll give you. You want my house, I will write it and give it to you. So everything is given, but at the lowest price, okay? So what happens? To an extent only they can deliver. So this is largely because we have been operating the solar plant or maintaining the solar plant in a coal-based power plant mentality. So 125 years before or 150 years before, when the steam plant came in, they were operating it in an expense model. They put 1,000 crore, 2,000 crore into it. Once the plant is commissioned, generation starts, then there is a COO who is given this year, this is your budget. Within this budget, you have to operate. So what happens? You start looking at break fixes, reactive. One gearbox fails, one drive conveyor belt fails, this motor fails, that motor fails, I do it. Or I take a calendarized step. Every month once I have to do this, every quarter once I have to do that. So based on these two things, if I see a pattern of failure, somebody takes proactive measures. So that's how it happens. And if you look on the right-hand side, about 1.5 gigawatt of wind and solar assets were assessed by McKinsey. and they say that if you follow the expense model, your plants will operate only for 88% of the time. That is, if your plant has 10 years life, it will work only for 8.8 years. If your plant has 20 years life, it will work only for 17 years. You are losing that 3 years life of your plant. It is not possible to generate. So if you run it in the expense model, what happens? You have inverters having problem. You don't have how to handle them. Next. Yeah. And then you have plants like this. We spoke about SPD and many other technological stuff. Even simple stuff, they don't maintain. Inverters, you have rodents getting attacked. VCB breaker panel is like this. And inside the VCB breaker, snake has gone and it got cooked up, or I should say got fried. And then you have plants like this. The string inverter is literally submerged. Konjam mala penja inverter theriyadu. So that's how it is. And when this is happening, at last, after 2 or 3 years, this is the stand you have. You don't know what to do now. Whether to call the OEM for support or to call the insurance to get claim. This is the where position we are in. So we have to move away from this particular situation of where am I going, what am I doing, into a different methodology. And this methodology is called as investment grade O&M. So in investment grade O&M, what happens is you have to move away from the maintenance model into an availability model. In the availability model, what you have to focus is you have to look at life cycle cost or life cycle based decisions. And you have to work activities based on your risk. Say, for example, you have a transformer. The transformer life is for 15 to 16 years. How do I make sure that the transformer works beyond that 15 years so that I don't have to replace? I have a string inverter whose life is 10 or 11 years. How do I make sure that I work it for 12 years, 13 years without doing any replacement or major repair? That should be the focus. So what happens today's buying decision is, I buy this inverter. Sir, SMA inverter is 3 lakhs, but I get some other inverter for 1.5 lakhs. Even if it fails, I will replace it for another 1.5 lakhs. So I don't have to worry. But what is happening is you don't know whether you will get the same component or not. 3 years back, 5 years back, you had 350 module, 350 watt peak or 375 watt peak module. Today, you don't get it. So power electronics is also in the same state. You may not get the same item. So what happens when you have a part and you want to replace it? It doesn't marry with other components. So your cost of replacing is very high. So you need to think about that. So that's why you have to make sure that the equipments live a longer life. This is one side, completely business, money related. On the second side, imagine that you are buying some electronic item whose life is only 5 years. You remove them, dump it and put new one. What happens to the faulty item? It all becomes e-waste and you are giving a very bad Mother Earth to your future. We are talking about green, helping make impact to the climate change. And what we are doing, buying crap and creating more crap out of it. Okay, so our focus should be on making sure that life cycle is improved with our O&M. And second, you have to base your actions on risk. For example, you have an older series of inverter. For example, the OEM has stopped those inverter manufacturing. The operation procedures for that should be different. Versus a newly launched inverter, the operational procedures has to be different. You have a project where the price per unit or PPA unit is different versus a lower tariff one, your action should be different. So you have to base your actions based on your risk and your risk appetite for that, rather than just working on break fixes and calendarized event. So McKinsey says that on the same 1.2, 1.3 gigawatt, when they moved from expense model to investment model, they improved the plant availability from 88% to 92%. That is, if your plant is designed for 10 years, it will work for 9.2 years. If your plant is designed for 20 years, it will work for 18 years. From just about 8 years and 16 years, you are getting 1.5 to 2 years more when you are looking at a plant of 20 years horizon. And this is where we focus. Our whole strategy is based on investment grade model. So when you do this, I'm not going to talk about what we can do, but I'm going to talk more on case study. This is a 1 megawatt poultry farm, very bad conditions. They all have been installed because good tariff was there in Karnataka, 8 rupees tariff. Tom, Dick and Harry went on installing it, and this is how the plant was. And that's an SMA inverter. You can see how shitty it is. And you go take the maintenance. So before and after, this is how the plant does. So it is just not visible changes, but it is also on the generation. So the same customer had 3 sites. We were managing only 1 site, and the other 2 sites, he did not get confidence because our O&M costs were a little higher. So he wanted to try only on 1 site. And you can see the visible change in the generation. Okay. And I'm talking about March to January here. Even in the poorer months where the irradiations are low, the plant has been growing. And the plant still has capacity to do better if the customer is willing to put a little bit more money to revamp it. So these are exceptional results where the plant is giving you 27% more generation simply by doing proper O&M. Simply proper O&M. Not like Jugadu O&M. Whenever I want, I'll go and clean. Whenever there is a problem, only I will visit. Not those kind of Jugadus. Proper O&M philosophies if you use. So this is another plant. This is a ground mount plant, about 22 megawatt. And you can see how we took up the O&M into it. We have reduced the monthly downtime from 42 hours to 4 hours in inverters. 42 hours of downtime to 4 hours. And these inverters are obsolete. The company which made the inverter sold the company to somebody else, and they are out of the solar industry itself. The company which took over is no longer interested in making central inverters. They want to focus only on string inverters. So there is no support for this. In such condition, how do you make sure that the downtime comes down? So you can see visibly from 88%, bringing the uptime to 100%. And not only that, you have to give financial budgeting. What you have to do more, right? What are the expected future costs that you have to budget now so that your plant is maintained at the same level? So that is the level of management that we have to do so that your plant lives longer. So this all can be done with a good field team, but to manage that field team, you need a good central control team. We call it as GRAC, Global Renewable Energy Asset Control Center, which is a network operation command center. We have a team of experts sit, monitor the plant remotely and assign. Okay. So that also looks like a very mundane job. It is just monitoring. But if you look at this with an inverter, okay, the inverter is not, the inverter rating is 175 kilowatt, but it is stopping to generate above 170 kilowatt. It stops. It clips for funny reasons. We don't know why it is. So classically, when you go to an OEM, he will say that it is not my problem. You are not maintaining the inverter properly. This is module side issue. There is no irradiation, no cleaning. So we have to wear the hat of an OEM and we have to give him enough data. Hey, look, I cleaned. These are the values before cleaning the module. These are the values after cleaning the module. These are the things that we have done, and still we have randomness in the inverters not performing. Only when you give all these data, the OEM thinks, okay, this guy has done proper analysis. Now I have to give a replacement. So we got replacement for those inverters. So you need a sound technical team which will talk the language of each stakeholder. So if there is a transformer related issue, you need to talk in their language so that they can understand. Because the first thing an OEM does when there is a warranty issue is to raise their hands and say, boss, you have done some mistake in installation or there is some site issue. Otherwise, my product is always good. Okay. It is like you have to prove yourself you are innocent until that time you are guilty. So that is the charge that our GRAC team does. Analyze data, give them proper reports so that we get warranty. Fortunately, we have a good track record of getting 90% of our warranty claims. We have failed miserably with Indian module manufacturers, some of them, but most times we struggle 3 months, 4 months, 5 months, we get warranty replacement for modules, inverters, transformers, and whatnot. Next. So this is another project where we have deployed. This is another Karnataka farmer scheme project, 2 megawatt, I think 2 megawatt. So here the plant was completely not performing well. The tracker guy is bankrupt and he is not helping. The trackers are not working. The EPC is not interested in doing small project O&M. They want to do only 100, 200, 300 megawatt. Their company has gone listed, so they don't care about small projects. So this is how the ST side looks, the transformer looks, and the plant was in complete shambles. So we took over the plant, and then we show them 27% higher generation. And this is by our SMS model, wherein we deploy our robots, our machine, our software, so that the customer doesn't have to worry about anything related to the technology being deployed. So this is another case study. We talk about very, very simple stuff, and this is another simple stuff which doesn't get taken care of. Inverter cooling. So in this case, there was not sufficient cooling, and because of which the internal temperature of the inverters were rising and the inverters were tripping. So we brought in an HVAC specialist, analyzed the air cubic that needs to flow to reduce it. They were having 4 air conditioners running at 20, 22 degrees to cool the inverters. Still the inverters were tripping during summer and they were consuming auxiliary power. And you know, in most of the states, auxiliary power for solar plants are charged at commercial tariff. That is, you are generating power, selling it for 4 rupees, 5 rupees, but your auxiliary power is charged at 12 rupees, 13 rupees. So we made all these changes, and then we reduced the auxiliary power consumption and helped them save 66% of their auxiliary power consumption. So these are real live cases where we have demonstrated why you have to have your brains into O&M. It is not somebody goes and mops it up and come. And then we talk about all this, but one thing doesn't change is you have to get to automation. Automation is not going to stop. You have to get adapt to it. Maybe you keep banging like this guy, but you have to bang with something new. So automation is going to change. You may not change, but the automation will change you. So you need different things. You don't need a simple daily generation report which comes on a WhatsApp, which says all inverter, this is the generation, or in an Excel sheet. You need ranked DGRs, right? You need to have different inverters, how they are ranked. So even in this case, you can see that inverter number 1.3 is 75.98 PR versus inverter number 1.1 is 5.1 is 74.5. So anybody would say, why are you rating a lower inverter at a higher rank? But I know that inverter 5.5 should be performing well, and it is always ranking at 1. 2, which should have done better than 75.5 to PR, is not performing. So I know the ranking has come down. So at minor level, even on daily basis, you can track the inverters underperformance so that you can catch them, the failures at a very early stage. So you need softwares which can understand or predict such failures. And then you need system generated analysis, which are very open and you don't have to fudge data. So this is another case where reporting is done. And you can see in 2020, any EPC or anybody would say that as per PVSys, I have achieved. For last 6 years, I have been achieving or exceeding. But as a O&M player, I felt bad that in 2020, my plant did not perform well because the PR went down. So we show everything clear to the customer so that they know what is happening in their plant and they can make the best use of the data which is available. And this is another idea that we brought in 2018 to understand failures predictions. So, and when we say failure prediction, when I said about warranty claim, these are the inputs which is helping us have a better relationship with OEM and help us get more warranty claims. So this is another classic case. It's a string inverter based stuff. Back then, that 50 kilowatt inverter was a hot selling cake. Many people went for 50 kilowatts. So my customer bought 300 numbers of 50 kilowatt inverters and they were all going up in flames. Literally, they will smoke and go up in flames. So we were doing some part of the portfolio O&M. So we had to analyze them. So we did analysis, and then we found out that it is a batch related problem. Then we said this is a batch related problem to the OEM. And the OEM then said, how are you saying it is batch related problem? Then we say, you go and do an RCA and say to me, these batch of inverters are not having this problem, but starting from this time to this time, we have problem. These are the starting numbers of serial numbers. So they picked up random serial numbers, did an analysis, and the report is here. The boxed item is the report from the OEM. He says that we have been using manual tightening mechanism on the IGBT boards. So the IGBT boards were cracking, so that caused the failure. We have ordered automatic screw runners to make it. So this is the advantage that data can bring in, not only for your customers, but for the OEMs also, to predict failures for them. Because otherwise you have to wait for 1,000 more failures to happen, what is really going on. Another failure prevention method wherein I can find out occurrences. This is again software driven, based on events I can understand. And these are our robots that we make, so they don't have to rely on any additional stuff. So these robots are tested. We just don't stop with cleaning. We have our own machines to do vegetation management. So they can be leaner, faster, and efficient. And they have GPS tracking also. So if you go to any utility plant and you ask whether grass cutting is over or not, sir, 15 days before I did, or 15 days after I'm going to do, but here it is like GPS track, you know what is happening, when, who did what. So all that is available. And drone, I don't have to explain. So as I said, automation and technology is going to take over. So we provide drone services also to do thermal imaging as well as security surveillance. And especially when you have parks of the size of 50, 100, 200 megawatts, you cannot have just the leg-based security system to work. You need drone-based security systems to have a better surveillance of your plants. And then this is least talked about topic in solar, but this is very common in any industrial segment. Even in wind it is there, but in solar, if you talk, people laugh at you. This is again a spare parts management system, wherein let's take, we can create a cluster, Coimbatore, Tirupur, Palladam, Bent as a cluster, and all the owners can come together and have a common spare part management system. I have few examples. This we did in Gujarat, near 150 megawatt, 3 customers are owning spares. If they would have bought spares separately at the end of 3 years, they would have spent 50 lakhs and they still wouldn't have any spare part left. They would still have to procure 1 lakh, 2 lakh worth of spare. But under the spare part management system, they would have spent only 59 lakhs or 60 lakhs. They would still have 50 lakhs worth of spare with them under the agreement. So what happens is it's a win-win. All come together, manage a spare. It is very common in wind. They call it as gearbox bank concept. It is the same concept which we have now. We manage about 2.5 crore worth of spares for inverters, AC breakers, and all this, so that we can reduce the downtime. Another classic case, but same SPA only. So the way is that you cannot simply do only with manpower. The way to manage your solar plant is to have softwares, machines, and resources which can do a complete turnkey. The customer shouldn't be worrying about whether the robo works, whether the robo is the latest technology, what happens to its spare. They shouldn't be worried about it. They shouldn't be worried about which software it is, whether it is integratable or not, what kind of report I will get. They shouldn't be worried. They should be simply worried about, I have put a solar plant, the IRR is this is the return ROI I'm expecting, and it should work. It is just like you go to a cardiologist to check your heart. You should come to an asset management expert and forget about your asset, and they should manage about it. So, as I said, investment model, software, machines, everything together, zero investment from the customer, and focused on improving asset life, improving the equipment life. In addition to that, 100% compliant to ESG norms, statutory compliance, and whatnot. A few minutes about my company. We started in 2015. We are only focused on technical asset management. Today, we have provided services to 1.5 solar assets and manage about 150, 180 megawatt of solar PV plants across 8 states. We are more focused on creating technologies. We spend close to 170, 150K US dollars every year on research and development. Many products we develop don't sell, but we are still happy trying our hands, making our hands dirty. And our focus is to make sure that the PV investment remains green across the cycle. That is why we have a 4-stroke engine to cut the grass. That's why our robots use less than 300 ml of water to clean modules. They can do both dry and wet. So everything we do, we focus on how we make sure that solar remains green as green. And then creating an improved asset life is our focus. Next. Recently, we got a grant from IIT and Department of Science and Technology to develop an software application. This largely focuses on forecasting renewable energy assets along with RE storage and whatnot, because with more penetration into the grid to make sure that the grid is stable, we are working with IIT Roorkee in conjunction with the Department of Science and Technology to develop this. And we strongly believing in giving it back to the society. We are just not focused on creating revenue or money for the enterprise. We work very strongly along with the societies, be it our support staff. Most of them were hired from very remote and rural backgrounds. They are first-time college goers, school goers. We get them trained in our curriculum and then we hire them. And in addition to this, we today support few emerging sports person so that they can excel well. This year we had a very good haul in medal sections in Commonwealth. Our kids who we sponsor one day finish in global podiums. So we strongly believe in giving it back to the society, just not creating revenue for our company. That's it. Any questions? Open for it.
Excellent session, sir. Just one, a few queries. What is your take on small rooftop? I have seen. I mean, it's far more difficult. There is far less money, but the problems, I believe, you also know, are bigger.
The rooftop by itself is challenging. Even in the commercial space, it is very challenged because of two main reasons. One, they are spread geographically so wide. We don't have, unlike a water purifier or an AC, you don't have so many installations that you can put in, average them out. So that is one thing. And second, today the market is in such a mode that everybody wants to try solar, right? There was a period when people used to look at, okay, I'm doing solar because I'm green conscious or to show it off. But today people understand the commercial value of it. So what happens, anybody knows S of solar is also installing solar. So that is the major challenge that we see. They all install. So we are managing, we look at a plant recently in this belt. The whole roof is carpeted. There is no way you can walk, do any maintenance activity. So people just wanted to push as much as modules into a DC capacity into it and do it. So rooftop is very challenging. So that's why we are coming up with an program called as on demand. So wherein just like how you book your Ola or Uber cab, you will be able to book it. We are working on partnership models so that we can have more partners who can work on it. And it just not only about service, it will give you an comfort with an extension of warranty also. Say for example, you are buying an off-grid system or an on-grid system, which is 3 kilowatt, 4 kilowatt, 5 kilowatt, and you can buy an extension of warranty. So when you buy the extension of warranty, we are mandated to come and visit to make sure that is the site worth to give the extension of warranty. So we have the backing and the technical expertise to regularly come and visit. So these are things that we are working now. Maybe in a couple of months or so, you will have a separate portal where people can log in and ask for extension of warranty. Right?
This is for inverter of the extension of warranty for what?
We are today focused only on inverters and major components. We are not getting into modules as such.
Modules also, it's a major issue. I don't know whether it's substandard in the rooftop segment compared to the megawatt.
See, you pay for what you get. You get what you get paid for. So I don't want to get into quality. there are two sides of the coin. There is one side, the OEM who wants to sell it, the other side, the customer who wants to buy it. So if the OEM is not strong enough to differentiate and explain to the customer why he has to buy a superior product, it is not the mistake of the customer. You and I go and buy shoes or whatever it is, you are always looking to reduce 1 rupee, 2 rupee in whatever you purchase, right? So it is for the OEM or the guy who is selling to explain, hey, you are buying X brand of shoe and your work profile is this, you would have a problem. So instead, you have to go for Y brand of shoe, which would help you. How it would help you? This is 100 rupees, this is 150 rupees, this 50 rupees will help you save it in going to an orthopedician for your knee problem. That kind of discussion do not happen today. So today what happens? I need to put a 50 kilowatt, sir, I'm also doing, sir. This model, everything, sir. He is giving 49 rupees, I'm giving 48 rupees, sir. That is how it is happening. That is where the major challenge is. And I don't blame the customers. The customers are not aware. They are more interested, but they are not aware. We paint a very bad picture to them. So I would say the OEMs and the EPCs and the installers are doing a very bad sales. That is on one side. And second, we are very good at leaving the money on the table. Even if the customer is willing to 2 rupees, you go and take it at, sir, I'll do it at 1.5. So it is on this side of the stakeholdership than on that. And there will be different type of customers. Somebody who will say, I want it at low cost. I don't care about quality, because you have people buying Oppo phone, also iPhone also. So you will have different type of people, and there are people to serve different markets also.
Yeah. One more question on your forecasting model which
Yeah.
you are trying with.
Yeah.
When the asset quality
Yeah.
itself is different.
Yeah.
I mean, I believe you would have also come across it, right?
Yeah.
Across plans.
Yeah.
Forecasting is a bit more challenging.
Absolutely.
I mean, how will you figure things out? I think.
Until March 2020, we used to forecast about 750 megawatt. We exited the whole business in April. We exited the whole business because of completely various reasons. Today, forecasting is more about how good I know the SLDC. It is not about what good technology you have. If the X company which is doing forecasting knows well that SLDC, they will manage it. So it is nothing to do with forecasting. So today, most of them do forecasting with Excel. Yesterday's generation, give it today. That's all is forecasting. But while this is said, we had classic case, as you rightly said, you're talking about asset quality. I'm just talking about data quality, right? We had a 5 megawatt plant where the SCADA doesn't work. And my team has to take 1 hour once energy meter data, give that to me, and I have to forecast. And I have to make sure that the customer doesn't pay penalty, right? So we have done it. We had 99% accuracy. Maybe I can show in one another presentation. We had 99% accuracy even with that data. You have to use the right models, but the model also takes time to stabilize. I don't want to use the jargon AI and the ML, but it is largely statistics which goes behind it. Today, mathematicians call themselves as artificial intelligence. But it is possible. Understanding the asset inferiorities and the data inferiorities, you can still be able to give a decent forecast, which would have a lower penalty.
Yeah. But I mean, still it's very site specific, right?
Yeah.
With all these assets of different quality being installed.
Yeah.
Especially the project which you're working on.
Yeah.
You're talking about the future grid and all that.
Yeah.
But there is absolutely no standardization. I mean, I don't know whether anybody will be able to give at least say 20%, with at least 80% accuracy, 90% accuracy forecast.
No, today, if you look at the challenge for India is our grid itself is in such a complex situation. If you take a smaller country like Philippines, Malaysia, Thailand, also, they have very decent grid. I'm not blaming that we have a poor grid, but based on our economic growth and growth aspects, we had to build sporadically where we want. So it is not a linear grid. It is completely messed up grid. Given that condition today, If the SLDCs start acting better, we will not have challenge. But I think under the One Sun, One Grid program, a lot of things are happening under the ISA also. So even this funding comes under the ISA. It is not part of the Government of India stuff. Though the fund comes from Government of India, it comes under the One Sun, One Grid. Because if I generate RE power and it is part of inter-country transfer, I shouldn't make sure that my mistake affects some other country, neighboring country. So these are cyber physical devices and softwares which will help forecast better. I think going forward, there will not be an option for you to have a poor forecasting.
Yes, I mean, at some point,
Yeah.
it has to be there.
Yeah. When in 2013-14, when 25 megawatt, 30 megawatt plants were being put, I used to work with SMA back then, and we used to say, you have to go for power plant controllers, and people used to laugh. Why should I go for power plant controllers? Today, you take all the tenders from SECI or anyone, it mandates power plant controls. So I think slowly what will happen is even the 5 megawatt, 1 megawatt, 2 megawatt will slowly have power plant controls inbuilt into it. And I'm pretty damn sure all these industrial clusters will slowly have power plant controls also, because once the substation solar saturation crosses 30 or 40%, automatically the grid operator will not have any choice other than saying, you don't worry what happens, I will mandate what your solar plant has to do. So that will slowly come. We are 3-4 years down the line, but all the plants will have centralized command control, which we don't. As a solar plant operator, they don't have any.
And then, I mean, we're talking about once we are discussing high voltage DC lines connecting, right? I mean, that's what.
No. I'm talking about, say, for example.
I mean, I understand that point.
Yeah,
it's a
yeah.
different question.
Yeah.
I understand what you're talking about.
Yeah, 700 volt HVDC lines you're talking about.
Yeah,
Yeah.
that is somewhere in construction or it's still theory, right?
No, that we are talking about high level evacuation. But say for example, you take Palladam substation, right?
I understand your point. I got it.
Yeah.
Basically, load management, when you have
Yeah.
excess power, how would you manage
Yeah,
it?
yeah,
That is
yeah.
40% evacuation.
Yes.
voltage.
So
And
these-
that is happening even at a localized level.
Yeah.
You see, if you take Kerala's state, where we have a lot of residential installations.
Yeah.
For one villa community, they are 75%
Load.
transformer load to be connected.
Yes.
If that 75% near 75%, you
Yeah.
see group tripping of inverters.
Yeah.
All that happens.
Happens. Yeah.
So I mean that is and they are clueless actually
Yeah.
because they are all single phase installers.
Yeah.
They don't even map whether all of them are connected to
Connected.
the same phase.
Correct.
To that level itself, they don't actually. I mean, I had actually given a white paper to Reese actually
Reese.
after collecting some data.
Yeah.
I told them that you should do it.
Yeah.
But at least mark which phase each single phase inverters are connected
Correct.
and allow the utility new guy to connect to the lower voltage phase.
Correct.
And have daytime load management, not just the night, because Kerala's peak is 7 to 10.
Yes.
So they do load management based on that.
Yeah.
Not on the daytime
Correct.
peak. The noon, everybody's inverter strips.
Yeah.
So
No, but on the DC side transmission, I think we are progressing, but we are late. That's what I would say. Yeah. But storage will come by then and would help suffice. Is my view. Yeah.
thank you.
Yeah. Thank you. Any questions? I hope I did not bore you guys.
Thank you.
Thank you.
Thank you, sir, for your information section.